These next slides I stole from a fellow at the South Dakota School of Mines. I'm not making any money on this. This is just for educational purposes, so hopefully the theft is warranted. I'm going to go through these slides relatively quickly. The point of going through this is to give you an overview of power systems. And as we work through the course, the first 8 weeks of the course, we're going to look at these different components in much more detail. And then in the second half, we're going to be looking at how you might operate some of this stuff. So we're going to take a quick look at power production, transmission, distribution, but primarily the big thing we do in this class is we spend a fair amount of time with substations. Because that's kind of the place where technicians in the high voltage realm actually operate, right? Linemen go and take care of overhead power lines and underground power lines for the most part. Now we are going to look at some splicing and some things, but where a maintenance electrician is probably going to most likely spend his energy is actually going out and operating high voltage gear in a substation. So that's kind of what we're revolving around. So here's a picture of the power system. We have some prime mover that converts energy into moving electrons. So we think of electricity really as an energy carrier. It moves electricity, or it moves energy. So we start out in this case with coal, and dirty, nasty coal, and we transmit it at some voltage, and then we step it up, usually something very high, move it a long distance, step it down, move it around a town, and then step it down again to be used by the customer. So these steps, substations, tend to be where technicians, maintenance, industrial type technicians, interface with the high voltage system. It's not the only place, but it tends to be the main place. Again, just another picture of the same thing. Some sort of power generation, changing one form of energy into another. Combustion turbine that might burn gas, a coal fire power plant, a hydroelectric power plant, and then transmitting it at some very high voltage, in this case 230 kV. And we do that because high voltage, remember the old power law, voltage or power equals voltage times amps. So if you, for a given amount of power, if you increase the voltage, you can reduce the amps. Less amps, smaller wire, less voltage drop on the wire. So that's why we step it up. And then it's stepped back down again for utilization. So we got different ways we can produce the power. The transmission system typically are relatively high voltages. In this area of Wyoming, most of the transmission lines are 230 kV and they're AC lines. All right, substations. Now, at any industrial facility of any size, you're going to have some substation equipment. The power utility is going to bring you power maybe at 69,000 volts, maybe higher, maybe lower, and then you're going to be converting that to usable voltages in your facility. So distribution, yes, there will be distribution in a facility, in an industrial facility. However, oftentimes it kind of hangs out there, and the maintenance electricians don't do a lot with it. They tend to get contractors that deal with it. Yes, they might energize a transformer or something, but typically they're kind of hands off. So we've already looked a little bit at one-line diagrams. I show you this slide just to let you know there are so many different configurations of substations. The one-line diagrams we're going to use in this class are very simple and straightforward. However, there are a multitude of different ways we can do a substation. These common electrical parts are called buses. So this is a bus bar. You might have a bus that is made out of wire. We call that a string bus. You'll see buses that are made out of aluminum tubing. You'll see buses that are made out of angle iron or copper bars in switchgear. Those are all bus types you're going to see and deal with in this class. So there's kind of the bus. Bus just means it's a place that is a common electrical place. And so substations really have two functions. They will typically change voltage, and then they change voltage and distribute power. That's their two things: change voltage, distribute power. And a kind of a third piece, they protect stuff, but it's kind of wrapped into the first. We got to change voltage, distribute the power, and then we tend to protect those different distribution circuits. We tend to protect the equipment that's changing the voltage. So the layout of these are very similar. The ones we use in class are going to be very similar. We're going to start with some high voltage. We're going to go through a disconnect switch. We're going to go through some sort of protective device, a fuse or a breaker, that protects the transformer. Transformer changes the voltage. We have another disconnect switch. Then we go through one or more circuit breakers or fuses to distribute power to one or more circuits. So these can be configured differently. Here's a mobile station. There are plenty of different ways to do it. So now we're going to just kind of look at some of the different pieces of equipment. Here's a station, with overhead power coming in. Here's our disconnect switch, and our protective device is right in here. Here's the transformer. Sorry you can't see my cursor very well. And here's a bus. And it looks like some voltage regulators, and then this is the distribution piece out here. And we're going to look at these in the field as well. Here's some bus. Notice this is all. This would all have a common voltage up here. This cursor's not going to work very well, is it? All right, we're going to be looking at all these different types of components as we go through. We're going to look at surge arresters, bushings on transformers, oil-filled bushings, disconnect switches, oil circuit breakers, also vacuum circuit breakers, air circuit breakers, different styles of circuit breakers, gas circuit breakers. We commonly now just call these power circuit breakers because there's so many different configurations. So this is a oil circuit breaker where it extinguishes the arc inside the oil. That's kind of old style hockey. Gas circuit breakers extinguish the arc inside a gas chamber. Yes. Here's an indoor circuit breaker, one that goes into switchgear. This whole thing stabs into the equipment. These are all things we're going to look at. Switches, cutouts. You're going to get to do some things with cutouts. So those are the kinds of pieces of equipment we're going to go through in the class. Transformers and how transformers work. The basics on how we maintain transformers, and that's the sort of stuff we're going to look at. Relays, CTs. Here's the fellow that put this together. Thank you very much. I think this guy must have helped him. All right, just nice pictures of different components that we might see in a substation. This is metal clad switchgear, so there could be breakers down in the bottom of these cabinets. CTs and PTs, we're going to spend quite a bit of time with CTs, PTs, and relays. CT stands for current transformer, PT stands for potential transformer, and these are what connect controls, meters and relays, little things, to big power system type things. There's some pictures of relays there. Relays are the brains for breakers. They tell breakers when to trip. We've already looked a little bit at one-line diagrams. Here's a one-line diagram. 52, that's a circuit breaker. Here's a little CT going to a relay. A transformer, notice it's delta Y. Power goes down through another set of CTs, through another breaker, and on out. And this 87, if you looked up 87, it would be called a differential relay, and what it's doing, it's comparing the power going into the transformer to the power coming out, and they should be the same, very close to being the same. Then there's something wrong and they trip. We're going to do a lot with substations in the next few weeks.